Hi, Honors Algebra 1. We are going to start our word problems. This is actually in the back of your Chapter 1 notes packet. And we've dealt with word problems before in the past, but now we're going to specifically talk about two uniform problems, uniform motion problems. So when we're talking about uniform motion, that means things are going on at the same time or more events are going on at the same time. So it normally leads with distance. So here in our scenario, we have Tanya, who's a long distance runner. So Tanya's involved, and she runs at an average speed of 8 miles per hour. 2 hours later, or 2 hours after Tanya leaves your house, you leave in a car and follow the same route. If your average speed is 40 miles per hour, how long will it be before you catch up with Tanya? So in these word problems, it is very important to define your variables. So you're going to define your variables depending on what information you're looking for. So the very last sentence tends to be the question what they're asking us to find. So in the last sentence, how long will it be before you catch up with Tanya? This is actually going to be our clue as to what we're going to let our variable be defined as. So we're going to let x, we're going to define our variable and let x equal the time it takes to catch up with Tanya. Now we are dealing with a distance problem, and there's a basic formula that is used for finding the total distance, and that is distance is equal to the rate times the time, or d equals r times t. Now mathematically speaking, that is correct, but sometimes you will see it written in the reverse way, which is rate times time is equal to distance. They both mean the same thing. However, it's very important to emphasize the different meanings of the words rate. So over here somewhere, let's go ahead and define, sometimes you're not going to see the word rate written. You may have other words written in place of rate. So sometimes, like in this case, they're going to tell you speed. So speed, these are some synonyms for rate. Some problems you may say speed, you actually may see the word rate itself. So obviously rate means rate. You may see the words velocity. You may see the words pace or momentum or rate of change. So any time that in a word problem that you see any of these synonyms here, they're specifically standing in for the word rate as with respect to the r in our distance equation. So d is for distance, r is for rate, and t is for time. So rate is again how long or what speed you are, whatever motion you're performing, like driving in a car. T is for time, how long in hours or minutes it takes to go that speed, and distance is the actual total distance. Now please know that it's a different distance than the length of 2 points. We're talking about distance is how far you went with respect to rate and time. So for example, let's say that I drove 40 miles an hour. That was my speed, and it took me 5 hours in time to drive 40 miles an hour. I could say that my total distance was 200 miles. So this is distance equals rate times time. So that's just an example. Now let's look at this problem here. Figuring out what's involved, we actually have Tanya and you guys are the distance runners here. So it would probably make sense to actually write rate, time, and distance. And if you want, actually it makes more sense if you go ahead and say rate times time equals distance. Now all we have to do, remember when we set up our word problems, we kind of do like a column, is we're going to say who's involved here. Now in this problem we have you are involved and Tanya the other runner. So we have Tanya and we have U. So sometimes we're gonna have a total column, but we'll see if we need that right now. So Tanya, who is a long distance runner, her average speed, which is her rate, is 8 miles per hour. So we're gonna write her rate is at 8 miles per hour. 2 hours after Tanya leaves your house, you leave in a car and follow the same route. So we're going to let X, because we defined that earlier, equal the time it takes, it should say takes you to catch up with Tanya. So that means your time is unknown, which is X. And if it said Tanya left, you left after 2 hours after Tanya leaves your home, you leave. So that means that Tanya left first. If you left 15 hours ago, she must have left 17 hours ago. If you left 10 hours ago, she must have left 2 hours earlier, which is 12 hours ago. So any time that you left, which is X, we're going to add 2 additional hours to Tanya because she was running a little longer. Now your rate is 40 miles per hour. So we're gonna go ahead and write 40 by the rate. Our distance here, remember, distance is equal to rate times time. So basically what we're saying is her rate, Tanya's rate of 8 miles per hour times her time of X plus 2. Remember, we have to multiply the whole quantity X plus 2 by 8. And this is equal to our distance. Your distance is equal to 40 times X, or 40X. Now, like I said, normally we would, when that says total, we would add things together. But in here, the question is how long before you catch up? So it's really important that you understand that catching up basically is saying, when are the distances of you and Tanya going to be equal? So in this case, we want to know when Tanya's distance is going to equal your distance. So in this case, we're going to set the equations equal to each other. So it's a little different than what we're used to doing. But again, remember, you have to multiply 8 by the whole quantity X plus 2. So in this case, we're going to go ahead and solve like we usually do. So let's go ahead and distribute. So we get 8X plus 16 equals 40X. If we go ahead and isolate by bringing the variable to one side, we're going to subtract 8X from both sides. Bringing it up over here, we have 16 equals 32X. Divide by 32. X is equal to 1/2. Now, remember that X represents time, and we're talking about hours because in our problem it was defined, it was per hour. So this really means a half hour. So again, if we go back into the problem and figure out what X represents, it represents your time that it takes to catch up with Tanya's time. So, in a complete sentence, you will catch up to Tanya in a half hour. Now some of you may say, well, can I write 30 minutes? Of course, a half hour is equivalent to 30 minutes. So however you want to write it with respect to the minutes or hours. Let's look at uniform motion problem 2. A biathlon is a two event happening here. Let's see, that means we have a run and a bicycle race. So our biathlon consists of 2 events, a run and a bicycle race. So you've entered a 62-mile biathlon. So this is important because this is our total distance of both together, the race and the run. And during your run, your average velocity, there's this key word here. Again, velocity is another word for speed, or our rate. So we know this is going to be a distance problem. Again, just on the side, distance is equal to rate times time. So the average velocity is 8 miles per hour during the run, so during our run. And then during our bicycle race, I'm just going to switch colors here. Our bicycle race, your average velocity is 20 miles per hour. You finish the race in 4 hours. Now, when they say you finish the race, they actually mean the entire biathlon race. So that means this is the total time that it took us to finish both the biathlon. What is the distance of the run and what is the distance of the bicycle race? So here they're asking for two things they want to know, the distance. So again, if I go ahead and write that I have my rate and my time and my distance, three columns here. But again, rate times time is equal to distance. Now, what's involved here, instead of two people, I have two events going on. So the two events that I have are a run and my bike race. So I could go ahead and input the proper things, except I haven't defined my variable. So if you look at the question, what is the distance of the run? It looks like you would want to put axis or distance here. But the thing is, we already have what our total distance is. So we're going to hold off on that yet because maybe we want to approach this a little differently. So right now, let's go and fill in what we know. So our run, our velocity or our speed or our rate is 8 miles per hour. In our bicycle race, our velocity is 20 miles per hour. Okay, so what we do know here though is a total amount of distance that the biathlon is and the total amount the race is as a whole. So we're actually going to want to add a little row here for our total. Now it doesn't make sense to put what a total rate is because that's all independent of each other. But the time of the biathlon, the total time was 4 hours. And the total distance of both events together was 62 miles. So that means if it took 4 hours total to run both races, I can go ahead and define my variable x as the time that it took to ran the race. So we could let x over here equal time to run. So how long did it take me to run? So if we define that as x, and remember we've seen this plenty before when we were dealing with investment problems, if our total time it took the biathlon to complete that event was 4 hours, and we spent X amount of hours running, then it took 4 minus X hours to find how long it took us to bike ride, okay? And then our distance is exactly rate times time. So again, where 8 times X is 8X. Here, the distance is 20 times this whole entire quantity, 4 minus X. So again, you have to make sure you put that in parentheses. Now we finally do have a total. So we're not trying to compare when we're going to meet up with the bike race like we did in problem 1. Here, anytime you have a total, you're going to want to add 2 things together or multiple things together to sum that up. So this is the distance of our run, this is the distance of our bike race, and it totally took 62 miles. So that means if I go ahead and add 8x plus the 20 times the 4 minus x, that total will give me 62 miles. Exactly the total of the biathlon. So if I go ahead and do some math here and distribute, I'm going to get 8x plus 80 minus 20x equals 62. And if I go ahead and distribute or simplify like terms, combine like terms, I'm going to get negative 12x plus 80 equals 62. If I subtract 80 from both sides, I'm going to get negative 12x equals, and if I subtract that, I'm going to get negative 18. If I divide, I'm going to get x equals positive 1.5. So that means, don't forget, I have to substitute this in for time, and I still have to find the distances once I substitute that in. So if I substitute in 1.5 here into time, that means my distance for my run was 8 times 1.5, which is equivalent to 12 miles. okay? And then my bike race is 4 minus 1.5 times 20. So that's going to be equivalent to 50 miles. So if I go ahead and add 50 and 12, that's going to give me my 62 mile total. So you want to write it, or I should say they want to know the distance. So we want to say that in a sentence. The distance of the run was 12 miles and 50 miles for the bike race. Okay, so you're going to try this one on your own. It's talking about inheritance. Try to figure out who's the person you know the least amount of information about, and let that define your variable. So you could try that one on your own, and then that's it for this day's word problems.